Hello everyone, I am Dr. Milikul Seth and today we will discuss ionic product of water. First thing is, this is also known as ionization constant of water. So before starting this topic, let us recall something about ionization constant. Remember when we were talking about the equilibrium, we calculated Kc for the reaction. तो जब भी कोई reaction equilibrium में होती है, हम उसके लिए Kc calculate करते हैं. How did we calculate Kc? For a reaction like A plus B, which is in equilibrium with C and D, we calculated this Kc as C concentration, D concentration product divided by A का concentration and B का concentration raised to power their stoichiometric coefficient. That was our Kc, called equilibrium constant. But when we learned Oswald dilution law, what we have learned? Oswald dilution law was explained by taking the ionic equilibrium. Ionic equilibrium of those substances या those electrolytes which are weak electrolytes, क्योंकि वही equilibrium में रहते हैं. Strong electrolytes पूरा टूट जाते हैं, तो उनमें हम equilibrium का concept we cannot apply on that strong electrolytes. So when we applied this concept of Kc, equilibrium constant, on the equilibrium called ionic equilibrium, we named that constant as ionization constant. I am just reminding you this, that if there is a substance called AB, which is an electrolyte, and on passing electricity it will dissociate as A plus ion and B minus ion. And just because it is a weak electrolyte, it is going to come into the equilibrium state, मतलब it will stop converting into its ion after a certain time, और फिर हम उसको इस पे we can use the concept of ionic equilibrium, because after a certain time that equation comes in the equilibrium state and it is appeared that it's not going on, it's not going to dissociate, it is not going to convert into its ion. तो ऐसा weak electrolyte के साथ ही होता है कि they do not dissociate at all after a certain time and they dissociate to a very small extent only. So we have seen this. If I have to write down K for this reaction, I will write it as A का concentration, B concentration divided by concentration of AB. So that was explained by Oswald in its Oswald dilution law, that how they are related with their degree of dissociation. Those who have done Oswald dilution law, it's fine. Those who have not done Oswald dilution law, they will go through this way. I hope it is clear. Now let us start with the ionization constant of water. And we know very well that water is not going to ionize to a great extent. It is not that much dissociation. There is not that much dissociation of water. Although water undergo the process called self-ionization, यानी खुद से ionize हो जाता है. Whenever I have to ionize HCl, मुझे उसमें water डालना पड़ेगा, because water helps in the dissociation of HCl. ठीक है, लेकिन water को कौन ionize करता है? Water itself get ionized. And what is this process called? Self protolysis or self-ionization of water. We have seen this in the chapter called hydrogen, जिसमें हमने water की property पढ़ी थी, and we have gone through this reaction that water itself get ionized, like one water molecule which will give its one H plus ion to the another water molecule, यानी H plus and OH minus, it will dissociate. ये H plus will be given to this OH2O, so that this will convert into H3O plus, and what is left out? OH minus. So if I am considering this equation, so if I have to write down equilibrium constant of the water here, I will write it as K constant, H plus ion concentration and OH minus ion concentration divided by water concentration and water. And just because this is in axis, this is not going to change at all throughout the time. पूरा टाइम इसका concentration नहीं बदलेगा, because it is an axis and very small amount of this water molecule will be dissociated. तो I can write it as, इसे H2O whole square लिख दूँ and यहाँ पे इसे transfer करूँ and I will take it as constant. This will be constant and it will be equal to H3O plus and OH minus, and this I am replacing as K replacing by KW है ना. So this is what H3O plus ion and OH minus ion. This is what we have. This is what we have. Ionic product of water. तो water के ions का product is called ionic product of water. I hope it is clear. अब इसे ऐसे करके देखते हैं. Let us apply the Oswald dilution law in that. So I am taking same reaction. So let's imagine, I'm just simplifying it right down by writing down this H2O here, which is dissociating to give H plus ion and OH minus ion. लिख सकती हूँ मैं इसे ऐसे. तो इसको और सिंप्लीफाई कर ले तो आई एम जस्ट टेकिंग दिस H plus and OH minus. Okay. And you know what? H plus ion concentration in the pure water at 25 degrees Celsius is found to be 1 into 10 raised to power minus 7 moles per liter. किसकी? H plus ion concentration. Okay. And obviously, if it is a pure water, the amount of H plus will be equal to the amount of OH minus. So this two will be seen. OH ion concentration will be equal to H plus ion concentration. So can we calculate Kw for it? Kw is what? Kw is H plus ion concentration plus OH minus, and OH minus concentration is the product. So what is this? 1 into 10 raised to power minus 7 and 1 into 10 raised to power minus 7. So what will be the answer? 1 into 10 raised to power minus 14. So the K value, the value of Kw, ionic product of water, ionic product of water is 1 into 10 raised to power minus 14. So now I am going to take one more concept here. When we have to calculate pH, what is pH? Minus log H plus ion. तो अगर pH is minus log H plus ion, तो क्या मैं pKw लिख सकती हूँ minus log Kw, है ना. तो minus log Kw मतलब log Kw means 10 raised to power minus 40, isn't it? So can I write it like minus log 10, sorry 14 log 10. Can I write it like 14? So can you see there? pKw of water at 25 degree Celsius. The value of pKw of water at 25 degree Celsius is 14, and it is a fixed value. It is a fixed value. So do remember that pK value 25 degree Celsius is a fixed value, and concentration of H plus ion is also fixed at this particular temperature. But when you increase the temperature, the dissociation of water will be more. तो जैसे ही water ज़्यादा dissociate होगा, H plus ion की concentration बढ़ेगी, and just because we are talking about the pure water, H plus के साथ OH will also be increasing. क्यों? दोनों बराबर रखने हैं. तो H plus ion and OH minus ion will increase in concentration. Hence, the value of this Kw will increase. So pKaw will decrease, and it is observed that at the temperature, it is observed that at the temperature 63 degrees Celsius, we have increased the temperature. At 63 degrees Celsius, it is found that pKw value for the water is 13. So pK value decreases on increasing the temperature because of more dissociation of water molecule. I hope it is clear. Now let us apply this concept of Oswald dilution law to the water, to the dissociation of water. देखिए जरा निकाल के कि how we are going to apply the Oswald dilution law concept. So just imagine that we have taken the concentration of water C moles per liter. ठीक है, starting में at t equals to 0 we have taken C moles of water. तो इस टाइम पे during the starting they were not formed. It is just started. At the equilibrium state, what has happened? C alpha moles were dissociated because alpha is the degree of dissociation of water. So C में से C alpha was dissociated. जितना amount of the water is dissociated, this will give you the concentration of H plus and OH minus, isn't it? So what is the concentration of H plus ion? C alpha. So what is C here? C is the concentration of water. What is the concentration of water? We have to take it in moles per liter. So let's assume 18 grams of water. मतलब क्या? 1 mole, which is the molar mass of water. कैसे निकालते हैं? H2O. I'm taking it here. H2O, 2 hydrogen and 1 oxygen. 1 oxygen मतलब 16 gram. So this is 18 gram of water. 18 gram of water equals to 1 mole. So 1000 gram of water will be equals to 1 upon 18 multiplied by 1000. Calculate करिए, you will get 55.5 moles. कितने में? In 1 liter or 1000 gram. In case of water, 1000 gram is equal to 1000 ml. So this is 55.5 moles will be present. So moles per liter में the concentration of water is 55.5. What is H plus ion concentration? We have already calculated this experimentally, that it is found to be 1 into 10 raised to power minus 7. So can't you calculate the degree of dissociation for the water? Alpha equals to 1 into 10 raised to power minus 7 divided by 55.5. You will find it around 1.8 into 10 raised to power minus 9. So degree of dissociation of water is too small. So let us apply this concept of KW, taking a question which is from the NCERT. So I have question here 7.65, question number. Just open your NCERT, try to solve it on your own. I am solving it in front of you. तो करते जाइए. Just give a pause to the video. थोड़ी सी देर रोक दीजिए वीडियो को. Try to do it on your own, and if you get it, it's fine. If you don't get it, then only continue with the video. Okay? So I am taking a question. The question is, it is 7.65 question. Ionic product of water. Ionic product of water is at 310 Kelvin is 2.7 into 10 raised to power minus 14. What is the pH of neutral water at this temperature? Okay, so you are given ionic product of water, that is KW you are given. What is that? 2.7 into 10 raised to power minus 14. As I told you, temperature playing a very important role. You can see there the ionic product of water is increased here. Ionic product of water at 25 degrees Celsius, what is given to you? It is 10 raised to power minus 14. So it has been increased here, you can see there. And what they are asking you? They are asking you to calculate the pH of the neutral water. यहाँ पे this important thing is here, neutral water. Water is having same number of H plus and OH minus ion. Neutral water means that. So KW is what? KW is H plus ion and OH minus ion. ठीक है, H plus ion तो OH minus के बराबर है, तो can't I write it like H plus ion square? KW की वैल्यू आपको दी हुई है, तो can't you calculate H plus ion concentration? KW is 2.7 into 10 raised to power minus 14. तो H plus ion concentration क्या होगी? रूट लेंगे सबका, रूट 2.7 into 10 raised to power minus 7. So this way you have taken root. H plus ion concentration calculate करिए. You will find it like 1.67 into 10 raised to power minus 7. तो H plus ion concentration is this. आपको H plus ion नहीं पूछी है. You are asked pH of the solution. ठीक है, तो हमारा काम हो गया. What we have to do? We have to calculate the pH. और pH कैसे निकालते हैं? pH equals to minus log H plus ion concentration. H plus ion concentration means 1.67 minus log 1 minus log H plus ion concentration is what? 1.67 into 10 raised to power minus 7. तोड़ दीजिए, लॉग प्रॉपर्टीज लगाइए, माइनस log 1.67 प्लस log 10 raised to power minus 7, and whatever you calculate you will get the pH of this water. pH of this water at the higher temperature, your answer will come around 6.8 to 6.9. इसका क्या मतलब हुआ? इसका मतलब क्या ये हुआ that your solution या तो water, neutral water ना, आपका solution नहीं है, this is neutral water, क्या ये acidic हो गया? We are not talking about the pH at the temperature 25 degree. What is the temperature here? 310 Kelvin. So you have raised the temperature, and on raising the temperature, pH decreases. If you increase the temperature, dissociation of the water will increase और H plus आयन बढ़ेगा. हम यहाँ OH को मेंशन कर ही नहीं रहे ना, H plus आयन बढ़ा तो pH उसका कम हुआ. But you have to mention here at this temperature the pH is 6.8. It does not mean that your water is turned into acid. It is neutral क्योंकि वो already mention कर चुके हैं. It is neutral and we have calculated it in such a way so that these two are having same concentration. तो टूटेंगे तो दोनों ही निकलेंगे, लाइक H भी निकलेगा, OH भी निकलेगा. बट जस्ट बिकॉज यू आर टॉकिंग अबाउट pH, H plus ion concentration you are dealing with, तो H plus तो बढ़ा ही ना, तो when the H plus is increased your pH will decrease. So you can say that the temperature is playing a very important role here. More is the temperature, pH will decrease. जैसे जैसे आप टेम्परेचर बढ़ाते जाएंगे pH कम होती जाएगी. बट यहाँ पर pH जब हम बात करते हैं, when we talk about the pH, it is more important to understand कि जब भी 7 pH होता है तो it is neutral, जब भी pH कम है तो we consider it as acid, and when the pH is more we consider it as a base. But यहाँ पे you have to mention that 25 degree Celsius पर 7 is the pH of the neutral water. ठीक है, 25 डिग्री सेल्सियस से ज़्यादा टेम्परेचर करेंगे तो pH कम होती जाएगी. जितना ज़्यादा करते जाएंगे डिसोसिएशन टू एन एक्सटेंट, एक लेवल तक, जब जितना ज़्यादा आप टेम्परेचर बढ़ाते जाएंगे डिसोसिएशन विल इंक्रीज एंड दैट विल डिक्रीज द pH. H प्लस आयन बढ़ रहा है ना, वो अलग बात है कि OH भी बढ़ रहा है, बट वो तो हम मेंशन नहीं कर रहे हैं, हम तो H प्लस आयन देख रहे हैं, एंड दैट इज व्हाई यू हैव टू मेंशन दिस थिंग्स. ठीक है, तो डोंट गेट कंफ्यूज्ड इफ योर pH इज फाउंड टू बी 6.8. आप डरिएगा नहीं कि क्या हुआ, ये तो मेरा सोल्यूशन एसिडिक हो गया. नो, इट्स नॉट एसिडिक. द pH मीन्स यू आर टॉकिंग अबाउट द पावर ऑफ H प्लस. पावर तो बढ़ी ना, वो अलग बात है कि दूसरे की भी बढ़ गई, तो हम उसकी तो पूछ ही नहीं रहे. वी आर टॉकिंग इन टर्म्स ऑफ pH. So I hope you know now what is ionic product of water and how to apply the concept and how the pH changes with the temperature or pKW changes with the temperature. If you like this video, hit the like button, share it, and please subscribe my channel. Thank you very much.